Welcome to the last video on word problems. We are ready to look at problem 9. So I'll turn on over. Again, I'm sorry, that kind of makes you seasick there. And this problem is talking about a cell phone bill. So we're back to something that's a little more concrete, not as abstract and far out as some of the things we've seen. A cell phone company charges a monthly rate of $12.95. So there's one piece. And 25 cents a minute per call. The bill for M minutes is $21.20. So how many minutes were charged on this bill? So think about this in everyday terms. You have a monthly rate that is fixed. That's constant. It does not change. So every month that I have this plan, I have to pay $12.95. Even if the phone sits in my purse, I still have to pay this constant. Plus, I have to pay for the minutes that I use. And they tell me that each one of those minutes is going to cost me $0.25. And I don't know how many minutes were used in this plan. That's what varies. In one month, I may not use a lot of minutes. In another month, I may use lots and lots of minutes. In my family, everybody's birthday is in December. So for me, that month would have a lot of minutes, where other months may not. But for this particular month, the bill was, that's the equal sign, $21.20. So I have built the equation that we need to solve, and let's go ahead and solve it. So here's the frame, and here's the problem. The constant plus the variable is the total bill, another constant. So this is definitely the constant side, and this is the variable side. So I need to move that $12.95. That needs to go over to the constants. And it's positive as it's sitting there, so $12.95 minus $12.95. So I'm left with the variable part equaling this total amount over here. And I know what that's going to be, but I want to make sure that it comes out of your calculator the way I think it will. So type that in there. Yes. And that is $8.25. And let's divide by the coefficient. And so M is 33. So for this particular month, I used 33 minutes of talk time. Not much, just a little over half an hour. But that's me. I text a lot. I don't use my minutes. I use the text feature. And this problem's a little old. Now most people have unlimited minutes or some other plan, but this one's a little bit outdated. But the algebra never changes. Okay, one more. And I decided to let us go out with a bang on this one. This problem is an economics problem. So you might see this in a college math course where you're studying the concepts of supply and demand, or how much companies have to produce to meet how much people want to buy. So let's read this one, and please don't panic. Just hang in there with me. We'll get it done. For a certain commodity or a certain product, the demand equation, giving demand D in kilograms for a price P in dollars per kilogram, is D equals 100 times 10 minus P. The supply equation, giving the supply S in kilograms for a price P in dollars per kilogram, is S equals 75 P minus 3. The market price is such at which demand equals supply. And we're supposed to find the market price. Now, a lot of people would just give up on this one. You can always just make a guess and keep going. But I want to show you that this one is doable. And here's why. The one phrase that I really, really like in this whole big mess is right there. That demand equals supply. So let's follow that idea through just a little bit. Demand and supply are the same. And this is a good situation in economics. This is called equilibrium, where people are wanting to buy as much as there is in supply. Okay, so let's go back through the problem and look for the word demand. So I see it there, I see it there, I see D, and then I see this. And that is what I'm interested in right there. And then I'm going to look for supply. I see it here, I see it here, I see S, and I see this, which is what I'm interested in. So all I've done, I've gone through there and I've looked for these two words, demand and supply. Well, demand goes with this expression, and supply goes with this one. And the yellow statement says that these two things are the same. So if you can get this far, you can do this. This is not an easy problem. Okay, we're going to use distribution. So I have 100 times 10, which is 1,000. And then I have 100 times negative P, or 1P, if you want to put your ghost in there. And then on this side, I have 75 times P, or 75P, and 75 times negative 3. Be careful there. Negative 225. And remember, these are equal. So we have the equation that we need to solve. Let's go ahead and set up a frame. So I'm left with 1,000 minus 100P equals 75P minus 225. So the 100P is negative, that's lower than the 75, so this is the boss letter. It doesn't matter, you can use either side variable. And then the constant is over here. So I'm going to bring this 100P over to this 75P, put those together. And I'm left with 1,000. Gonna need a little more room, so let's come up here. Is 175P minus 225. So let's add 225 to each side. And 175p equals 1225. And the one more step is to divide this by the coefficient. And so P, I'm going to have to move over here, comes out to be 7. So the price for this product is $7 per kilogram. That is a tough problem. We are finishing with a tough one. But look at how much you've learned. Look at how far you've come since that very first one-step equation. There is a final exam on the next page of the course, and I would encourage you to try that, see how you do. That's a good indicator of how much you've retained from the course. Remember, if you have questions, you can certainly contact me. The contact information is in the introduction of this course, so you can go back and take a look at that. And I've enjoyed working with you. If you decide to take more courses with me, I'll see you in future videos. But good luck to you in whatever your next step is going to be. And don't let math scare you. You can do this. It's doable if you learn the rules. Thanks for your time, and contact me if you need me. Bye-bye.